Welcome everyone to part 2 of 7.4. We're talking about the geometric mean and similarity in right triangles. Now, we're going to pick up where we left off, altitude geometric mean theorem. Now, in order to understand this, we have to first kind of label our triangles here. So we're talking about, we have our big triangle. Okay, our big triangle is ABC. We have a small triangle here. It's ADC. And then, let me go ahead and just fill that in completely. And then we have a medium triangle, which we're going to call, oops, let me rewind a second. We're going to have a medium triangle here that we're going to call ADB. Okay, all right, good. Actually, that looks pretty good. All right, now, what we're doing here is we're comparing, let's see which ones we're comparing. Well, it says AD over CD. Well, let's find where AD is. AD is only a part of one specific triangle. It is only part of the small triangle. See that? Right here. AD. It's definitely not part of the medium triangle at all. Doesn't touch any side of it. And it's only a small section. It's not even a complete side of the big triangle. So it's only part of the small triangle. So clearly we know that we are comparing, let's move over here. This is the small triangle that we're comparing on the left. Okay, so this whole left side is going to be the small triangle. Now AD, what side is it? Now this is where we're going to go based off appearances. And as long as we're going off appearances and we set up a geometric mean, we're fine, okay? And I'm going to explain what that means a little bit later on once we get to some examples. Stay tuned for future videos. Now, this AD side is the short side. Remember, we're trying to label based on short, long, and hypotenuse. So we're comparing the short side, and CD is clearly the long side. So we're comparing short to long. Now, if we compare short to long on the left side, then we also have to compare short to long on the right side. This is going to be short to long. Don't want the equal sign. Short to long on the right side also. Now, which triangle are we comparing? Well, we're talking about CD again. Okay, CD, which triangle is it a part of? Well, CD is right here. Okay, so if CD is right here, it's definitely not part of the, it's part of the small triangle, but we already compared the small triangle on the left. It's not part of the big triangle, so it's definitely part of the medium triangle. The medium triangle is going to be on the right. So everything about this one on the right is the medium triangle. Now, we already said we're comparing short to long. We have to be consistent on the left side and the right side, comparing short to long, short to long. So the short side CD, that makes the long side DB. So DB is going to be the long side. Now, this is always going to be the case. If you're comparing the short to long side on the left and right side, you're always going to be talking about the small triangle being compared to the medium triangle, okay? So if you're ever comparing the small and medium triangle, you're always going to be comparing the short and long sides, okay? That is a key thing to remember. Small and medium triangles, you're always going to be comparing the short and long sides because that's all they have in common. Notice how they don't have the hypotenuses in common, okay? Whereas the long side of the small triangle, is also the short side of the medium triangle. They have to share a side. In this case, they do. They share this CD, okay? The CD, the geometric mean. This is very important. If they have a geometric mean, then we can compare them. And this makes it useful for us because then we can solve for the missing side because we have a geometric mean. And I'm going to kind of show what that means in just a second. Okay, so here, let's have an example. Here's our example. We have this big hypotenuse drawn here, labeled here. That's for the big side. We have this hypotenuse, okay? And we have, looks like a small triangle here. Okay, and then we have a medium triangle over here. Okay, let's fill this in. Getting a little picky here with the drawing. Really shouldn't take so many chances coloring it in. There we go. Okay, so we have a medium triangle and a small triangle, and obviously the big one we see there. Now this one's saying 2 over x, okay? If we're looking at this small triangle, this is the short side, this 2 is the short side, and this x is the long side of the small triangle. So we're comparing short to long here. Anytime we're comparing short to long, that's because we're comparing the small to the medium. It's just how it works. Okay, the more you do this, the more you see that this is how it's going to be. This hypotenuse, that's kind of to throw you off. You don't really need to use the hypotenuse of the big triangle here, but it's good to know to be able to recognize that this is the hypotenuse of the whole big right triangle. Okay. Something else that needs to be said. Well, it's very important that we recognize the right angles. Okay, so it's important that we see right angles here. Just as a FYI. Okay, sorry, I digressed. Let me get back on track. So now we have to say, okay, x, what part of the medium triangle is that? That's the short side, and it has to be the short side because what we compare on the left, we have to compare on the right. We have to compare short to long. So the 8 is the long side. Yes, it's the long side of the medium. Okay, and the reason why this works is because we have a geometric mean right here. Okay, we have to have that geometric mean. Now, the reason why geometric mean is important is because we have 2 variables. Okay, so we have a variable here and a variable here, and usually like, oh man, I have 2 variables. Even though it's the same, usually that's problems for when I cross multiply, it's not. Okay, so what we're going to do is we multiply x times x, we get x squared, and then we get 2 times 8, and that gives us 16. So we take the square root of both sides, and we get x equals 4. So now we have this missing length right here. We have the altitude, which is 4, okay? And that's how we apply it to these examples. Now let's talk about the hypotenuse leg similarity theorem. Okay, now with hypotenuse leg, we're going to be using the big triangle, okay? So what can we say here? Well, we're going to highlight our big triangle. All right, there we go. Okay, and there's actually 2 things we can say here. If, and then we have this, if there's, this is given right here, okay, and we have an altitude drawn, let me see if we can highlight it, altitude drawn there. So we have our big triangle. I'm going to highlight our small triangle, and actually I'm just going to do the outline of this one, okay, just to save some time. We have the outline, okay, and then I have the outline of the medium triangle, because remember, we always create 3 triangles with 1 altitude. Okay, so if we're given that altitude, then we can say, all right, let's make some comparison. And now we're talking about hypotenuse, so we have to first find the hypotenuse. The hypotenuse of the big one, okay, hypotenuse of the big one is clearly AB. Find the 90-degree angle. If you're having trouble with finding the hypotenuse, always find the 90-degree angle, and it's the side opposite the 90-degree angle. Okay, so in this case, our hypotenuse for the big one is going to be AB. Okay, now we need to compare it to a leg. So we can actually compare it to either leg of the hypotenuse, or of the big triangle, okay? Because we're highlighting the big triangle here. There's the big triangle. So we're doing AB over, and let's just pick a leg. So we have 2 legs. We have CA or CB. So let's start with CA. Okay, so this was a hypotenuse. And this happened to be, which leg is that? That's the short leg. It doesn't matter which one we compare. Okay, so we're doing AB over CA. Now, this is going to be equal to what? What will it be equal to? Well, it's going to be equal to, okay, it's going to be equal to another hypotenuse. So this hypotenuse here on the top, let me change colors here. This hypotenuse on the top needs to be equal to this one on the bottom, this short side on the bottom. So what has a hypotenuse of CA? We're looking for CA as a hypotenuse for a shape. So if we look at the medium triangle here, drawn here, this is the medium triangle, it's CB, that's no good. Okay, so look, CA is the hypotenuse of the small triangle. So actually, let me change this color here. I'm going to change it to red. CA. And we have CA again here. over its short, that was the hypotenuse, over the short side. The short side of the small triangle is AD. Okay, now you're probably like, okay, how did I know to compare that? Well, I just picked a comparison first. I picked a comparison with the big triangle. I said hypotenuse over the short side. And I'm just saying, okay, can I find a comparison to make with one of the other triangles? And I can make a comparison, okay, where there is a shared side. The shared side in this case is right here. It is the short side of the big triangle, and it's also the hypotenuse of the small triangle, okay? They share that in common. We have a geometric mean, okay? Now, we can also do the same thing with the medium triangle. Let me move this over. Okay, so I compared the hypotenuse to the short side on both the left and the right. Now watch how I can do the same thing with the medium triangle. So I'm going to do big triangle again. I'm going to compare the hypotenuse again, AB, but this time I'm going to go the long side. The long side, the long side in this case is CB. So let me choose a different color. Let's go this pink color, CB. Okay, so what did I compare? I compared the hypotenuse over the long side of this triangle. Okay, and we're going to set that equal to, this time, the hypotenuse, okay, the hypotenuse. Well, which side has a long side? Which one, if we're trying to compare a hypotenuse on top, which one has, sorry, wrong color. Which one has a hypotenuse of CB? Well, the hypotenuse of CB is this medium triangle. So the medium triangle is the one we're comparing because it shares a side, okay? Let me erase this, actually. The medium triangle shares a side with the big triangle. The side it shares is the hypotenuse. The hypotenuse of the medium is the long side of the big triangle. So CB is actually the hypotenuse, okay, the hypotenuse of the medium triangle. So this is over my long side of the medium triangle is simply DB. Okay, remember, we're looking for a geometric mean. As long as we establish a geometric mean, we know we created a ratio that is good. Okay, we have to have that geometric mean, and we have it there. So there's our two ratios there. I hope these triangles helped to kind of show you what we're looking for. Okay, and now let's go ahead and apply it. So we're going to apply it here. We have this little shape here. We have a missing value x. Okay, see how it's part of the big triangle. It's part of the short leg of the big triangle. Okay, so we say 4 over x. 4 is what? What value is 4? 4 is the hypotenuse of the big triangle. So we can say this is the big triangle we're comparing here. And the x is the short side of the big triangle. So again, we have to compare the hypotenuse over the short. If we do it on the left, we have to do it on the right. Now, the hypotenuse of x is what hypotenuse? X is going to be the hypotenuse of the small triangle. So this is the hypotenuse of the small triangle. And then 1 is clearly the short side of the small triangle. We have a geometric mean. That's what we're looking for in these problems. We have a geometric mean. Okay, so we can go ahead and cross multiply and divide. Or if you want, there's a simpler way to do it too. Once you get in the habit of this, we're going to have x squared, x times x equals 4 times 1 is 4. We're going to take the square root of that, and we get x equals 2. So another way to, anytime I see this geometric mean, you can just take the square root of whatever that other side is, 4 times 1. So the square root of 4 times 1, and you get your answer. So we have x equals 2, and that's how we do geometric mean for the hypotenuse leg similarity theorem. Now we're going to have one more part 3. If you want to see some more examples over different problems, stay tuned for that. We're going to do a concept summary also.